So I thought today we would go through been working a lot on the passkey stuff. Been working on this, just a bunch of different examples. This is the start of a weekly, just like coding session that I'm trying out, where we just go through all kinds of different random stuff. I've got loads of ideas for things we could cover, both on the kind of classic Stellar side and the smart contract side, but generally just trying to level up knowledge, answer questions, uncover both Stellar related things as well as just generally like how I deploy apps. There's all kinds of things that you end up touching when you try to deploy something online, whether it's Cloudflare related items and how the Stellar SDK, the support for that has been iffy at best. And there's some new updates that are coming for that, or variables, like trying to get environment variables sorted, what should be on the server and what should be on the client. Use of AI helps. Lots of interesting things we could cover. But today I do want to talk a little bit about smart wallets. That'll be obviously a big feature for us upcoming, trying to get that out there more. And I did a demo. You've probably seen the Do Math demo, where you're just kind of this stateless policy signer. So apologies if this is old news, but even if it's not, there's obviously a lot of background here that we're not necessarily going to get into here, but where you essentially have the ability to create this smart account, this Sorabon contract that is an account that you add signers to, and then we have this new ability to add policy signers, which essentially allows you to create a signature or a signing object that you can hand over to somebody else, and it only can sign according to a particular policy, a policy being another smart contract. So the Do Math example has a contract policy that essentially says the only thing this additional signer can do is call the Do Math function on the Do Math contract. So when you add these signers with a policy, you can like safely hand over a secret key to somebody, and all they can do is math. I'm going to demonstrate that really quick. So we're attaching this new ed25519 signer on top of our smart wallet. So now there's both a passkey signer, the SecP256R1 signer, and the ed25519 signer. The problem being, and I think if we look this up on like Stellar Expert on the test network, we should see those two signers, the ed25519 signer and then also the SecP256R1 signer. And you can't really necessarily tell what these particular values inside of this vector are, but these include limits being additional requirements that have to be met when that signer is used to sign for something. So in the case of Do Math, when you use the secret key for this ed25519 signer, it's allowed to do anything at the moment because we just added that signer, so it can both do math. You'll notice there's no pop-ups in this particular case because it's just using that secret key, which is super cool. But the big issue there being they could also do transfers with that secret key, which is definitely not something that we want them to do, which is where policies come in, where you attach a policy, in this case editing or modifying the ed25519 signer with a limit that says the only thing that signer can do is called Do Math contract, and inside that Do Math contract the only function they can call is the Do Math function. I don't know how fast this thing updates. Yeah, so it's still not pulling in the limits, but now if we tried to do a transfer, it would fail. And if I do a share here and I paste this in the chat, everyone can go, and I just leaked a secret key on Discord, but no fear because it's attached to a policy signer, assuming that I did my coding correctly. And if you go and you try and use that to do anything like stealing all of my money, it will not let you do that, but everybody will be able to do math on behalf of my CCQ account, which is super cool that I can safely leak secret keys. Don't let that get out. Cool. Well, that's that piece, but that is a stateless. So let me see if I can pull up this do math contract. Got so many contracts. There we go. So inside of this contract here, it's a very, very simple policy. So this particular contract policy really basically has nothing in it other than the only thing it's allowed to do is call do math, and a limit on a signer for this smart wallet contract is two things. It's a contract that it's allowed to be called on, and then the actual contract policy itself. So it's like a combo of two things. It's not just the contract. So you'll notice in here there's nothing that's like limiting for the actual do math contract. It's assuming that you will add this policy to the do math contract. So a signer limit is actually this combination of both of these things, which maybe will throw a little bit, but important to note. So anyway, in that particular example, there's nothing really fancy going on here. It's just one function that's a policy function, which is boring. Interesting, and it's nice that it's so small, but I also wanted to give an example for a stateful policy. So policies that almost act as protocols themselves. And so in that particular instance, we have this safeguard contract service. Let me just go ahead and give a quick demo of that. And I put out a video on this, so apologies again if this is old hat, but we're intending to look primarily at the code today. So this creates another contract, but then it's also setting up the policy, and the policy is like this, it's this stateful policy. So there's more things than it is doing than just signing or creating this policy __ method, which it definitely has that, but that's going to serve to actually like perform all of the limits when the policy is being called to, in this case, do a transfer. But the stateful part is the rest of the contract. So you'll notice this is coming from a policy interface, which comes from the smart wallet types that are built into that particular smart wallet policy or smart wallet contract. So you can import that. And one of the, maybe a little pro tip, something fancy and fun that you may not necessarily know is this is coming from a policy interface, which is coming from the smart wallet interface crate, which I'm actually importing from GitHub. So as part of my workspace dependencies, I can set up this smart wallet interface crate and link it straight from Git. I can even target a particular branch to get myself this interface dependency that comes right from Git. So I don't have to like install it to the Rust crates or anything. I can get it straight from GitHub, which is super nice because then as I make updates to the interface as needed, it gets very easy to like pull those updates into a completely separate repo. So I get this policy interface. That's what I use to actually just update this policy __ so that we make sure like we're following the correct pattern that the interface expects. But everything else outside of this, so the actual contract code, the stateful contract code, is all just custom, whatever the heck I want it to be. So I just kind of set up a contract and I make two contract implementations. One is going to be for this policy function for the contract. The other one's just going to be all my arbitrary stateful logic, which is quite nice. And all those stateful pieces are things like an initializer, which gets triggered there at the beginning here, as well as this add wallet, which is what gets triggered when you push that button. This initializer sets an admin key. This admin key just so happens to be the wallet itself. So in this particular case, every single contract deploys its own version of Safeguard. So there's like an admin in this particular instance, and then that admin is going to create a bunch of sub-wallets. But every time you open up a new Safeguard page and log in, it triggers that off again and actually deploys a brand new Safeguard policy contract. So there's not like one that everybody's using. Every individual contract in my instance has a new version of this Safeguard policy, stateful policy contract. And we can actually look at that code. It happens inside of all of my DApp client-side code is inside components home. All of that is coming from this init wallet function. So it's this pretty beefy method that's actually creating a custom contract. So it takes the WebAssembly file, which doesn't change, or the WebAssembly hash, and then just deploys a brand new contract and then initializes it and actually attaches a new admin to it. Does some funding for it to make sure it's got some money so that the whole thing is set up. And we can get into that code in a minute. But let's go ahead and for now go back to the policy itself. And there's really only a couple, I think there's like 3 functions other than init, which really just sets up the admin key, which again is the wallet key. So every contract will have every new deployment of this policy will have its own wallet admin. And then when you're adding wallets, you're technically just adding these like sub wallets, but 2 things happen because we've got the policy and we've got the smart wallet. So on my smart wallet, I need additional signers, because essentially what's going to happen here when I add new signers is I add ed25519 signers as these sub accounts on this account that have permissions to spend the main account's balance. So each of these accounts that I add, each of these sub accounts has permission, each of them, to spend the main account's balance, but only under a certain set of parameters. And those parameters are what the policy sets. So that's what this piece is kind of allowing. And that's the pieces that are also stored. That's the kind of stateful pieces. Each one of these wallets has its own piece of state that's stored in the policy for how much it's allowed to spend and how often. And so we can create a bunch of these and we can update them to be a different interval. So in this case, it's every 10 ledgers, this account can spend 100 stroops. Every 10 ledgers, this one. So you could update the ledger number, you could update the amount so that these accounts could have more or less, but they're all spending the same account's balance. So again, if we go to Stellar Expert, we go to the test network and we look up that account, you'll see both of those signers, those 2 ed25519 signers that have these limits. This is that policy contract address. So it has to call that policy contract, the policy, and this is the actual policy address that it's going to be calling, which has the policy __. So that's all well and good. We don't need that one. We just need this one. And so then again, if I spend this, I won't have any pop-ups because it's in ed25519 that just has saved the secret key, in this case in local storage, but you could do this all in a backend if you wanted to. And then if I try to spend again, I get an error. It's too soon. I can share this again, and everybody can go and try and spend all of my money, with the idea being you should all get errors until it's been 10 ledgers. And at those intervals of 10 ledgers, you'll have permission to spend those 100 lumens again. So I have safely, again, given away a secret key that actually allows you to spend this balance, but only once every 10 ledgers for these keys. The 3 methods here that are available are the add wallet, which is that one that we trigger when we click the little green button here. And what that does is get the admin address, which again is the wallet address. I don't actually technically need to save this. I could pass it as an argument, but because each policy is directly connected to the wallet itself, I thought it was a good idea to more directly link those things together, even though it wouldn't work if you didn't pass the right argument. It's kind of nice to have it baked in. But again, because this is a policy, or this is a smart contract, you could modify this, change it however you wanted. But anyway, I get that admin address, which was saved from that initializer. I require auth on that. That's actually what fires off the smart account, the smart wallet. That check auth piece, which then will do the actual policy checking. In the case of add wallet, I'm going to be using the SecP256R1 pop-up for that. So that's because I need the admin's signature, and the only admin key that I actually have was when I initially signed up, it added that SecP256R1 signer. But then you'll also notice like what's actually going on here is it's adding a new signer directly inside of the policy. So the policy, which will eventually be added, like the policy will add itself as its own limit on the smart wallet, which is kind of cool. Like there's not two steps, like two transactions that have to happen. You've got this smart wallet client, which again comes from the smart wallet interface. You spin up a new instance of that, and then it's got these methods like add signer, remove signer, all those pieces that come from the smart wallet interface. And then I'm going to hard code a brand new ed25519 signer. Instead of doing that like with passkey-kit or something, it happens right inside of the add wallet function in the policy, taking in the user's public key, which is this bytes n32, which is coming from this signer type, which again comes from the interface for the smart wallet. I say I want this user address. I don't have any, this none here is the expiration ledger. You can explicitly set signers to expire after a certain number of ledgers, or I guess add a certain ledger. Otherwise, you can just omit it. So I don't care that this expires. So I'm not going to set a limit on it or set an expiration ledger. And then I can set up limits. Those limits are a map, as I have mentioned, and that map contains two things, a key and a value. The key being what contract can this ed25519 sign. It's limited in scope to only being able to sign for particular contracts. In this case, it's a transfer for the Stellar Asset contract, which just happens to be whatever address is being passed in as an argument for add wallet. So when you add wallet, it's limiting based on that addition to a very specific Stellar Asset contract. In my case, I passed the native XLM asset, but it's saying this key, this ed25519, is only allowed to sign for contexts that are from this particular Stellar Asset contract, in my case, the XLM one. But then additionally, there are some additional checks that I want to include on that, and that is this policy call of this contract itself. So the policy is adding a wallet to its stateful storage, but also requiring that when it is called as part of this check auth, it has to call itself and pass its own check auth or its own policy call, which is what this will fire off, which is quite cool that we can do all of this just within a custom add wallet function. And then finally, we store the user with the passed in interval and amount. So the number of ledgers that it's allowed to call for and the amount that it can call per that interval. And that is add wallet, which is the main one. The other two are pretty simple. You can just remove, which just passes in the ID. You'll notice that two things happen though. It needs to get removed from both the policy storage and it also needs to get removed from the smart wallet itself. So we need to toss it from both places. So instead of passing it as two transactions where you remove it from the wallet and you remove it from the policy, I've just included a policy function, which ensures that we remove it from both. So remove it from the persistent storage of the policy and we remove the signer, all based off of that user ID, which again is the public key. So that one's quite simple. The update wallet, pretty straightforward. You just pass in a new interval and amount. And if those are both passed in, I'm going to keep 10 and I'll make this 10,000. We sign for that with the admin key again, which would be that SecP256R1, where it updates the sub wallet. That update then gives us a 10,000. So those are the only functions on the stateful policy. And then we can look at the actual policy underscore piece. And there's a lot of if statements, but that's just narrowing down this particular, like the contexts that come in. And this has to do with the way that when passkeys are running that check auth function, when say you're trying to make a transfer, right? When you're trying to spend lumens from this particular account, that transfer calls a check auth, or it calls require auth, which then fires off the check auth function for this passkey wallet, this smart wallet. And then when it calls that, it looks up the contexts and sees if there's any signer that has been included. Let me pull up, because I think this, like it's XDR. So oh shoot, I just did it, which now I've got to wait 10 ledgers because it's blockchain and it actually works. Oh wait, maybe we've got these guys. Let me see. I have no idea which one's which, but let's try this one and see what it looks like. If we go to laboratory, view XDR, make it big. Let's see what this one, yeah, so this is a transfer. Yeah, I don't know if I can make this, let me see if this kind of, so it's, yeah, not the easiest to look at. Let me see if I copy this JSON and then paste it here, is it a little bit easier? Yeah, perfect. Let me save this as test.json so that it formats like JSON. So essentially what's happening is I'm trying to call a transfer function for the native XLM token. I'm calling it for 70,000, which may be a little bit surprising. But the way that my protocol works is it stacks. So if you've skipped, like if you've waited a few minutes, in my case, looks like I waited about 7 minutes between intervals. You're only allowed to call once per every 10 ledger, but if you have missed calling it for those minutes, it stacks. So if you've waited 7 minutes, that would be 70 ledgers. So it would be 70,000 stroops. So that's why you see this particular one. You don't have to do it that way. It's smart contracts, so you can do it whatever you want. So let's take a look at the actual JSON though for the actual transaction. You'll notice there's this auth function. So this is like how things get constructed when, all right, you want to make a transfer, but you can't just steal money. You got to authenticate for it. You'll notice that the source, the address for the credentials for this Sorbonne authorize entry or Sorbonne auth entry is that smart contract. So that's what we're needing to authorize. And then we have a signature for that. And that's where this signer comes into play, where the key of the signer is the actual, in our case, the public key. And then the signature is the signed payload. So you build a payload out of the function, you sign that payload, and that's what the signature ends up being. And that's really all there is to actually getting the signature signed. There's like these pieces, and this is like what PasskeyKit builds for you, are things like this signature map, as well as getting all of the read and writes correct and the budget stuff and whatnot. But at the end of the day, when you're signing something, since we're signing for an ed25519, we just need the public key and then the signature for it. So that gets signed, and that's what it looks up. So when this goes into the check auth call for this particular smart wallet, it's going to look at the contexts, which would be this guy right here. And it says, oh, okay, you're trying to call this Stellar Asset contract. You're trying to call a transfer function. Cool. Do you have any signatures that actually have permission to sign for something like this? Well, it looks at the credentials. It looks at the auth array. It sees that you've got a credential here. That is this public key. Cool. All right, we'll look up the public key in that smart wallet to see if that public key actually has permission, the appropriate limits to actually sign for this. And that's what it does, which is where all of that limit stuff then comes into play that you added inside of add wallet. It looks and it sees, okay, well, it has a limit. It's not empty. And so is the limit, does it pass for this particular context? It looks to see if the Stellar Asset contract in that signer limit matches the address here. I'm sorry, the address for the actual Stellar Asset contract. If that does pass, then it goes to the next check, which is this vector here, which says, well, does it have any additional signature requirements? And in this case, yes, it does. It needs to call the policy. Okay, well, we're going to have to do a cross-contract call then to go back over and call this this policy. And that's when you get into this like big, long if statement, is it passes in a context, which again is like this chunk right here, and says this is the context of the call. It's got a transfer. It's got some arguments. Now you need to write a policy that will actually check for all of those instances, so that essentially what you can do is give a yes or a no on whether or not this particular contract invocation for a transfer on this smart wallet has passed. So again, it is a lot of if statements, but it's not that complex, so we can walk through it. I just want to make sure that there's only one context, so I don't want to inadvertently say yes to something inside of the context array that I haven't explicitly said yes to. So I'm only checking for one particular context. So I want to make sure there's only that one. If there is only one, we continue on. I only want to sign or approve for ed25519 signer keys. So a signer is passed as one of these arguments. And I want to only sign for ed25519. It's definitely hard-coded. It's not a requirement, but to make it easy for me in this particular demo, I'm only allowing ed25519 signers. Okay, so we pass that. We go on to the next context. There are multiple different context types. I only want to pass ones that are of contract contexts. So these would be contract invocations. You can also pass things like contract creations, and we'll be including, I think, a new one in protocol 20. What's the next one? Protocol 22. So these can grow. These can be multiple different contract contexts. I want to make sure I'm only limiting in this case to ones that are invocations. So if that passes, that's going to ensure that I'm like continuing to narrow down this yes, 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 yes. I want to make sure I'm only passing for transfer functions. So I look at the function name, see if the symbol short to the function name is transfer. If it is, we move forward. We want to make sure that we have an amount. Like there's nothing in here that says transfer function names are most definitely Stellar Asset contracts. So we need to keep narrowing down to things like, does it have an amount that is of type I-128? We kind of continue to narrow down for these particular types of transfers. And then once we're all the way down and it looks exactly like a Stellar Asset contract transfer function call, that's when we get into the meat and potatoes of actually doing the interaction of checking for the arguments. So the arguments in this case are things like the amount, the from, and the to, which we don't really need to care about like where it's coming from or where it's going to. That's checked with these storage items. In this case, the interval and the amount, where we want to make sure the interval is correct, where you're not trying to do this transfer too soon. And you're also, for the argument amount, you're not trying to transfer for too much. Assuming those things all pass, we update the state with the new previous time, or I'm sorry, the new previous time being what we just called the current time. And if all of that passes, all of our if statements, all of our storage checks, then we return to kill out this loop and return the function. That check auth inside the smart contract will pass. But if anything goes wrong, we just throw with a not allowed. Okay, that was a ridiculous amount of information, but that is basically the meat and potatoes of how this particular stateful contract works. I'm going to take a breather and answer any questions that folks have, both by looking through the chat, and then Elliot, I don't know if you've got anything on your end.
So one of the questions early on, Raheem asked about the context and if that's similar or the same thing as like the call stack in the invocation.
Let me pull
myself. I had a question about, you've used kind of wallets, sub-wallets, signers in some maybe fuzzy ways. Maybe you could describe those a little bit and kind of distinguish between them.
Yeah, so let me start there. The problem is that people have called these things many different things. A smart wallet is really, that's like the root of what we're talking about. That's the account. I will refer to it sometimes as a wallet or a smart wallet or an abstract account or a passkey wallet. All of those terms, except for maybe passkey wallet, are pretty accurate, where it's really just, it's the smart contract that holds the balance. Well, it actually doesn't hold the balance. The stellar asset contract holds a reference to the account, but it's like, this is the address. This is the thing that you're going to pass around. This is the thing that like owns, holds, is the thing that you would consider like this would be a corollary to like the G address. That's the wallet. That's the smart wallet. That's the smart account. What used to be called the passkey wallet. Inside of that, that's the thing you look up on Stellar Expert. When you get into sub accounts, these are not themselves smart wallets. These are just signers attached to the passkey wallet.
Okay.
The smart wallet. They can be of multiple different types of signers. Right now we have 3. One is a G address signer. One is a SecP256R1, so an ed25519 or a SecP256R1 signer. Those are 2 cryptographic signers. You can add as signers to your smart wallet. You can also add policies themselves as signers. That's a little bit less common, I think, than attaching them as limits to signers, because signers can have signing limits that limit what contracts they can call, and also additional signers that those signers may need to include when that signer is used. So you can create these pretty complex scenarios where, yes, I have like the main bank, the main house, but then there's a door that I choose to include on that bank that requires 3 different keys. That's what these would be. And those 3 different keys may require additional, parameters. So you have a lot of flexibility, but these signers themselves do not hold balances, or they are not themselves like smart wallets or accounts. They're either ed25519 signers, SecP256R1 signers, or policy signers. And all of those signers can have limits that say, or filters, or whatever you want to call them. I call them signer limits, that basically say the signer can't do everything on this account. And where like Classic Stellar had like thresholds and weights, I have smart contracts and additional signers that are attached to those signers. So it's like, if you could have added a signer rather than giving it a weight of 3, you could say this signer also has to include these signers, and this signer also has to call this smart contract, but it can only call this one smart contract. So there's a lot of flexibility for each of these signers to have a very specific set of additional limitations, such that I can click share and give you a secret key that doesn't give you access to do anything on my account. It can only do whatever that account specifically is allowed to do. Like in the instance of a signer here on this smart contract, it has a signer, so I could give you this public key, but you're only allowed to call this contract, and it also has to call as a cross-contract call this policy. So the policy has to pass, and it can only call for this particular, in this case, the native contract. So this signer, this G address, is only allowed to call the native asset contract, and it has to pass this policy check in order for this key to actually be used to sign for any sort of context. Does that help a little bit?
Yeah.
And then the other question was the call stack. I feel like call stack means different things. Like it means something very specific in the case of an error, where it's like, here's all like the things that were cross contract called up the stack, which maybe is a little bit different than the way checkauth thinks about call stacks. So let me show you this smart wallet interface itself. And this is very specific to checkauth, where you have this auth context. So checkauth is a special function that's given to us by Soraban, by the protocol itself. So this is not something I invented. It's something that exists on contracts. Contracts can choose to include a special function called checkauth. We're about to get another one called constructor. So it'd be underscore constructor. And it's a system level function that can be called within the contract itself. So constructor will be like, instead of having to have factories and do these double contract calls, we'll be able to deploy a contract and call a constructor. So we don't have to have two contracts to like initialize a contract. We can do the initialization when the contract is deployed. That's one example of one of these special functions. This one is where we get custom auth, where we can build our own custom functions when a contract has require auth called on it. So in the case of like remove signer or update signer or add signer, you can see I'm doing require auth on the current contract address. This also happens in a transfer. So if you use the contract of the smart wallet and call require auth on it, like a transfer does, it will eventually boil down back to check auth. That will get automatically fired when require auth is called on that contract. When that is called, it comes with a set of arguments. And some of these are customizable and some of them are not. Well, actually, one of them is customizable and two of them are not. Obviously, env just comes as standard. The signature payload is just a hash of the actual signature that's coming in, the thing that's getting signed. So it looks at the context of the whole authorization stack and hashes it. It's a little bit tricky to figure out what that is. I have lots of example contracts that work at getting at the signature payload. But ultimately, this will be the thing that your cryptographic signatures sign that you will need to make sure matches when you actually do the verify inside of a cryptographic signature. The signatures argument is customizable. This is what gets passed in the case of, I think I probably, oh no, do I still have it? Yeah. This is what gets passed here. This is the signature argument. And this is customizable. You can choose how you want to pass in signatures, kind of however you want. If you're signing with, I think there was one, I can't remember, so I'm not going to get into that. But this is customizable in the sense that I make up my own types signature. It's going to be of the ed25519 or the SecP256R1. So depending on what I'm passing in, it will be of a different form. So this is a custom one for the SecP256R1. So it'll have a couple of different items.
So Orban doesn't dictate what that signature struct looks like, correct?
Yes, it does in the case of a G address signer that hasn't passed a custom check auth. But that's a little bit, it's not so much outside the scope, but it's not relevant for writing your own custom check auth. Like you can make this whatever you want. In my case, signatures is actually a map. If I look up signatures instead of signature, I think it's actually in, oh, here it is. Signatures is a map, and its key is signer key, and its signature is an optional signature. So that signature being either an ed25519 or a SecP256R1. And that's why you see inside of this, you see signature as a map here with these different keys and values. Because you can actually pass multiple signatures. It's not a one sign. You can support multi-sig if you wanted to have ed25519 signing and SecP256R1 signing, or 10 different ed25519s signing. You can sign multiple. But because I also wanted to limit duplications on signer keys, and I wanted to make it really easy to look up to match contexts to particular signer keys, I made it a map rather than a vector. They're just like different design decisions that have been made as I built it out. So that's signatures. Again, build it how you will. This is the way that I've chosen to do it. It's working pretty well. The last piece, and this is relevant to the stack traces or the auth stack, whatever you want to call it, is just a collection of auth contexts. And these are not, unlike how you've got this operation, you've got this invoke. This is the actual arguments for the invocation, and then inside auth you have this root invocation, which also has sub invocations. And if there are sub invocations, those sub invocations can have sub invocations. This is the stack. Like when you think of a stack, this is where the stack actually is, not inside of checkauth so much. Because you may want to sign like a whole composed thing. Like what you don't want to have happen is like at root have all of your invocations and inadvertently sign for something that could be taken out of context. And like you sign for some deeply nested 100 lumen transfer, sign for it, and then that signature could actually be used outside of the stack context. So technically what you want to do is like stack the whole thing together with all of its cross contract calls, all of its cross contract calls being sub invocations. You want to sign the entire stack so that the entire stack has to be there when the signature is actually verified, when this particular bytes, right, the signature gets verified. I want the whole stack all put together, including all sub invocations, all the appropriate cross contract call nesting and stuff, so that nobody can go in and snipe my signature and use it for something that I actually didn't intend. So it's this composed, nested structure of any involved cross contract calls, and it's the safe way to do it. Once you get to check auth inside of auth contexts, all of the contexts, all of the cross contract calls, root contract calls, all of those calls are not nested. They're just the context. So you've got a list of everything that was invoked as related to the particular signer in question. So the address that was called when check auth was called. So that may be nested, right? I may call check auth for a particular function, and then inside that function, I call transfer on that same address, that same require auth. And so it basically pulls all of those addresses together. It's like how we called check auth on this poor address many, many times. It puts those all into this vector, which includes all of the contexts in which that one address, in my case, looking back at this address was had require auth called on it. But those will all be at root, like those, there's no nesting going on. So essentially what that allows you to do is just loop over all those contexts and basically ask the question, are we good? Like, am I okay with this context being called or being authenticated? And that's where you kind of have this matching between the auth context and looking up the signatures. So we loop, and this is inside, again, the actual smart wallet protocol that I've built. It loops over all of the contexts and then tries to find a signer inside the signatures map that is appropriate to actually authorize that particular context. And so some of those might be nested, but I may do a transfer inside of a context, and I might approve the transfer function, but if my signer has not approved the outer invocation, then that signer shouldn't be allowed to authorize that outer. But because there's no nesting, you kind of have this ability to say, this signer can sign for the transfer, but somebody else is going to have to sign for the outer invocation. Maybe that's a whole nother signer. Maybe I put 2 addresses on the signer limits for that, I don't know, ed 25519. There's a lot of customization, but it is important to remember that these contexts, they don't have nesting. They're all at root based off of the actual address that was called, that require auth was called on. That is definitely some advanced stuff, but it is really powerful when you start talking about how check auth actually works and the dangers kind of involved with doing things that have a lot of contexts or multiple signatures. Other questions? Things that have popped up? We can definitely start getting into some of the client code, if not.
Silence had a question about prepaying gas without using LaunchTube. Not sure exactly. Yeah.
Let's see. Yeah, some.
Believe that
you have to. So because contracts
can't be a source.
Yeah, contracts can't. Oh, am I muted? No, I'm not. Contracts can't pay for fees, so there's no way for a contract. But you could do a repayment, where a contract could essentially pay some other account to sponsor, but it's not this direct thing. And part of the problem too is like you don't actually know how much something cost until after the execution has happened. There are some interesting things you could do with like indexing using maybe Zephyr that TDEP has built to like observe when the transaction gets submitted. You look at how much it cost and then automatically call like a transfer function, but that would be a little reliant and centralized to ensure that there was repayments, but that's probably fine. Eventually I'm hopeful that contracts will be able to pay for fees. It does get a little dicey though, because again, if like you're in an instance where there's a lot of like logic that says what a smart wallet is allowed to do or not do you even want it sponsoring fees, or are there limits on fees? And so now you may have to do like a cross-contract call whenever a smart wallet is trying to pay fees for a transaction. So I don't think it's like, I think it will be interesting, but I don't think it's that interesting. Where I think the more interesting thing is just keep having G addresses pay those fees and then find good models for users to offload those fees back to either the protocol or the application. Ultimately, I just don't see a world with any sort of adoption where users have to pay for individual transaction submissions. For the amount of things that users will need to do to actually sign for, I don't see any user being okay with like continuously paying for those things and being aware that they're doing that. I mean, it's like you'll have to find some like monthly subscription model or something, and they get 100 transaction submissions. Like all this stuff will have to be obfuscated away. It'd be like asking users to pay AWS credits when they're using your application. That's kind of the world that we've been living in, and I think it's one of the reasons we just don't see people using blockchain at all, like in any sort of mass adoption way. I mean, there are many reasons, but that's certainly a huge one, is users just are not going to do that. That's crazy, that they're going to have to create some exchange account, transfer this magic money into their wallet that they don't even know exactly what it is, just so that they can use some application. Like, can you imagine using a bank and every time you wanted to do something like log in or transfer money between places, you're like paying not just for the transfer, but these fees to like use their infrastructure. Like I can understand a 10% fee to use their service. I cannot understand having to pay like their service costs for their own infrastructure, which is essentially what we've been doing, and it's ridiculous. Which is why I'm excited about services like LaunchTube, because even though, somebody's still got to pay for it, or you've got, it becomes like this service that either the protocol or the backend uses, you'll just have to figure out a way to bill your users in some other form, which I think is normal and is the only way to like ensure that we reach any sort of mass adoption. There is some questions around like, okay, but if I want to make a decentralized service that doesn't really have a central place, well then, don't use LaunchTube. Those are going to have to be power users. But if we want mass adoption, somebody has to own it. Somebody has to keep it online. Somebody has to update it. Somebody needs to make a profit from running that service. And capitalism can take over where people have different services, different front ends. Like the front end does not need to be decentralized. That's the beauty of the internet, is websites are proliferous. You can make a front end pretty easily, and then figure out how users pay you for using your superior, simpler front end. That's my opinion. That's the world that I want to see. I think that's the one that makes the most sense, particularly in like this bridging between Web 2 to Web 3. I don't think we get users to use this if we don't have some sort of corollary user experience that actually is similar or sane or at parity or better, versus 10 times worse than what they currently use, where they don't have to think about AWS or the services and the infrastructure behind the tools that they're using. Rant over. Use LaunchTube. I think I saw another question up here about passkeys being domain bound. The Safeguard SDK lets users to log into different domains using the same passkey wallet, or are passkey wallets rooted to one domain? All passkeys are rooted to a singular domain, which is I wouldn't say it's a massive gotcha, but it's certainly something to keep in mind, right? If I take this passkey and I go to something other than safeguard pages.dev, I can't use that passkey, which effectively means this wallet is like only for this domain, which sucks. That's not optimal. What's nice though is that you can add multiple passkeys So you could essentially say from this domain, if you wanted to add it to another domain, you just go to that other domain, make a passkey for it, and then add that passkey to the wallet. This is essentially how Super Peach, which I definitely think is probably down. Yeah. Oh, I think it's actually pages.dev. This is how, no, it's not. Oh, it's because it's superpeach.xyz now. This is how Super Peach works. Where essentially you've got this like super wallet that acts as your source wallet. And then all other domains go back to Super Peach and say, hey, I've got a new domain that I want to connect to my wallet, this particular contract for this domain. Can I please add it? And Super Peach can do the review and say yes or no to it, or the user can. But rather than there being like individual services that all create a brand new contract, you use the same contract and then just add different passkeys to that root contract. Coinbase does something kind of similar with their keys. I think it's keys.coinbase, but they're different in the sense that everything always comes back to this domain, even in the case of contract invocations. So whenever you want to use the wallet, the smart wallet, the passkey wallet that you added or created on coinbase.com, all of those transactions, those unsigned transactions, comes back to wallet.coinbase.com. You review it, you sign it, it gets approved, you get forwarded back to the domain you were on, which I think is bad for two reasons, maybe more, but at least two. The first being like you lose context. So you're in your domain, you're playing your cool game, you go to sign for something and it ships you off to Coinbase, which kind of breaks the flow, shows a pop-up. You're like, oh shoot, what is this? I don't want to be forwarded off to Coinbase. I want to just be in the game. So I don't love that. The other thing is if Coinbase, their domain, their root domain ever goes down, you're hosed. Like you can't actually use your wallet. Like they don't own your wallet. The keys, like the secret keys, are safe. But if their domain goes down, you can't load up their domain to actually get the pop-up for signing something on that domain. And that has happened where the Coinbase wallet address domain goes down for a bit and nobody can use their passkeys. So the way that I envision it is, yes, you have superpeach.xyz or freighter.app or whatever it might be, but the only thing it's used for is that initial adding of the passkey to the contract. But then you go back to your domain and you can sign. So instead of having one signer tied to the domain and you just have to be sent back to the domain all the time, you had many domains as signers to that one contract. And then you never have to go back to the domain. You can be on mycoolnft.app and sign for things directly there because you added that passkey to the same contract. So it's one contract with many domain signers. But that is a really good question because that is a problem with passkey. Nah, it's not a problem. I actually really like it. I think it keeps phishing down because they can't like fake you with saying it's Super Peach and swap out the E for a 3 and now you just got hosed because you put your secret key into the wrong. Like if they switch the domain, then you can't use the signing keys. So it's actually really good that you can't pass passkeys around to different domains. It would be nice maybe if you could explicitly like go to, wherever it's stored and say, hey, I'd like to add some approved domains to this passkey, but they haven't done that yet. But what you can do in my particular instance is just continue to add signers to the one key that are those passkeys tied to different domains. And now you both have the freedom to use those different domains and no singular reliance on a singular domain, but it all uses that same single contract. What about having a browser wallet? So I'm going to read through some of these. I'll probably read through all. I don't know if there's like a bunch of questions that I've missed, but I'll read back through these. We're at time now, but I'll answer this one. What about having a browser wallet extension that just hosts? I really hate the idea of I want to see a world where all of this stuff just goes away. I don't think users should have to download anything. That's just a weird experience to say, hey, welcome to my site. Before you do anything, I need you to go to another site and create another account. Sure, maybe it's a passkey wallet, but I actually have no confidence that the domain is ever the same. I have no confidence that you can move your passkey to a different, like if I had my passkey in Chrome, could I also use that same passkey in Safari? I don't think so. I'm confident that those domains would be different. I'm not sure that the domain isn't just like Chrome. Like, is it unique to the individual installed extension, or could all of my extensions now use my passkey? I would really hate that. So a little more research would have to be done, but I don't see a world in which you have to, like the whole point of passkeys is there's nothing you have to install. It just works. And I also think there would be significant limitations, even in the case that, yeah, there's still a domain at some level. I think it's Chrome : / in the case of a browser. But if I go to my phone, does it use the same thing? I don't even know if Chrome on my iPhone has extensions. So I probably couldn't even use my passkey on my phone. Sure, you could maybe add some additional signers, but now that you're adding additional signers, I don't know why you're using an extension in the first place. So I want to see a world where there's nothing to install. It's just a website that maybe is your root. But even in the case of the root, you might use Superpeach. You might use maybe Albedo adds this, maybe Freighter adds this, Xbowl adds this. You can pick which like root wallet you want to get the same contract address, but then you just add domains based on wherever you're on blend.capital. And they're like, hey, you want to log in with Superpeach, or you want to log in? And you're like, okay, yeah, I'm using Superpeach. Cool. Add a new passkey. They get the passkey. They forward it on to Superpeach, and it adds that new domain bound key. It's very, very similar to the way OAuth actually works today, where you sign in with Twitter or you sign in with Facebook, and they give you a little pop-up that says, this is what the account wants to do. Are you okay with that? Yes, I am. But you don't have to create a new Twitter account for every single app you're on, which is, again, kind of the world that we'd be in otherwise.
Yeah.
And the way the Coinbase, man, the way they're doing it is basically like, use the same password everywhere and hope that your service doesn't go down, or hope the website doesn't go down. Otherwise, you're not going to be able to log into anything, which I don't love. And again, I think they're probably going to end up fixing that with multi-sig of some sort. Okay, awesome. Any final questions or comments? Otherwise, I think we'll call it a wrap for today's coding session, and we'll get back to it again next week.